Okay, so here we go with zero product property. Again, this is going to utilize factoring, but you can read this: zero product property, two quantities are multiplied together, the result is zero. You know, a simple problem to think about would be if I told you A times B equals 0, you know through multiplication one of those has to be 0. That's the only way to get 0 as an answer. So here's the steps that we're going to look at. You want to factor a GCF if it's possible. Okay, we're going to factor and then factor using box diamond or difference of squares, and that's what we've been doing. Okay, and stopping at this point in time, just writing our answer. But now we're going to take it a little further. We're going to take each of those parentheses and let them equal 0, solve those equations, write your answer as an x-intercept. Let's take a look at what this looks like. So again, look for a common GCF. It's not there because this one doesn't have a number and this one doesn't have a letter. Therefore, we jump right into box diamond. Again, we got to start to get this here. Some of you are struggling a little bit. I question how hard you're working on it. Okay, because the pattern is the same every single time. All right, so this is the setup of the problem. Negative 8x squared goes in the top of the diamond. What do we multiply for negative 8? That adds for 2 is what we're trying to ask ourselves there. Obviously, there's only two ways to multiply for 8. 8 and 1 can't get 2. 4 and 2 can get 2, so we're going to go positive 4 and negative 2. Okay, we have to have a negative because the 8's negative, but the positive has to be bigger because this number's positive. We fill those into our box. Okay, we write our solution here, x and x, negative 2 and 4. So there's our parentheses. So the factored form of this is x plus 4, x minus 2. Okay, because we're finding the x-intercepts, we let that equal 0 because y is 0 at the x-intercepts. Zero product property says that if I split those up and let each of them equal 0, I will get my x-intercept. So I solve this, x equals negative 4. Solve this, x equals 2. And I write my answers as x-intercepts. So negative 4, comma 0, and 2, comma 0. That would be the places on the graph where this parabola touches the x-axis. Try another one here. Same process. All right, they all have numbers, but look, even, odd, even, not going to have a term to be factored, and no x here. So we're going to jump right into box diamond. All right, and I want you to go ahead and try this one up until the parenthesis part, and then check back. All right, so that's what we end up with. If you need to pause and observe this, please do. Split this up. 2x plus 3 equals 0. X plus 2 equals 0. All right, I'm going to two steps here, minus 3 and divide by 2. So I'm going to end up with x equals negative 1.5. And here I'm going to end up with x equals negative 2. This is a good thing, okay? Because way back when we were first learning about investigating a function and you had a parabola that touched at a decimal point, we were not able to figure that out. Okay, well, this gives you an alternative. This gives you an algebraic method to solve for those x-intercepts. Okay, so again, these are the x-intercepts, right? That's where the graph touches the x-axis if you were to graph it. All right, let's try one more example. Okay, oh, this one's a little different. All right, there's no common GCF because we have no numbers here and no letters here. It is not going to be using a box diamond because there's not 3 terms. Okay, so we want to look at our only other way that we've learned how to factor, and that's difference of squares. So x squared already is a square. 9 would be 3 squared. And I saw somebody do this the other day, and I thought it was a pretty good idea. They actually just wrote them out. Okay, because they know x and x make x squared, and they know 3 times 3 makes 9. That was a great idea. Okay, so whoever that was, kudos to you. I can't remember which student it was. And then we end up getting x plus 3, x minus 3. We still let them both equal 0. That's what zero product property says. And we get negative 3 and we get positive 3 for our x-intercepts. Again, don't forget, the last step is to always write them as a coordinate because they are. They are the coordinate where the graph touches the x-axis. Zero product property.